All right, it's another one of these, this time because I'm gone at a meeting this afternoon, so I thought we wouldn't waste a day. We continue to work on our solving of systems of equations. This time you'll notice it's by multiplication. So we've done graphing, we've done substitution, we've done by adding and subtracting, and now we're ready to eliminate by multiplication. So it's really similar to elimination by adding and subtracting. If you remember back to yesterday when we did that, we had those opposites that existed. So we had like 2x and negative 2x, or we had 8b and negative 8b. And if we didn't have those opposites right away, we could easily make one appear by just subtracting the entire equation. That idea of distributing a negative to make the opposite signs match on one of the terms to eliminate it. So instead of just distributing a negative or subtracting one of the equations, this time we'll have to multiply both sides of the equation to create opposites. Every once in a while it'll be the case that we might have to multiply both equations. And keep in mind that you can multiply the different equations by different numbers to achieve your goal. So you don't have to multiply both equations by the same number, but you should multiply one equation, both the left and right side, by the same number. And then in the other equation, you can multiply by a different number, but again, both to the left and right side. And then really once we've got that, it's just the same as adding and subtracting, where we eliminate the variable, figure out x or y, and then just plug that x or y back in to get whatever's missing. So we'll look at a couple of examples here. All right, so to start, we've got 5x plus 6y equals negative 8, and then our other equation is 2x plus 3y equals negative 5. Get my pen pulled up here. All right, so yesterday we would have had an opposite appear, or could have easily made one appear by just doing some subtraction. This time we don't. So what we want to look at is like the x and the x in both of the equations. We could maybe make those opposites, but we'd have to multiply both equations to do that because there's no, I guess, common multiple of those other than just multiplying both of the equations to achieve that. So I'm focusing on the y's, and I'm seeing that 6y and 3y. If I take that bottom equation on both sides times negative 2, I'll make that y, that 3y, change into a negative 6y. Then I'll have opposites. So let's see what happens there. Top equation, it's just going to stay 5x plus 6y equals negative 8. And then the bottom equation is going to change to negative 4x. If I distribute there, I've got minus 6y. So there's my opposite. And then on the right side, don't forget to multiply both sides. I've now got a positive 10. And I can go ahead and add those up. So it looks like I'm going to have just an x left over. Those are going to be canceled with the y's because they're opposites, like we said. And then equals, it's like negative 8 plus 10 would be a 2. So I've got x equals 2. It comes out pretty easy for us after we find that opposite, after we create that opposite. And then to figure out what y is, let me just plug x in. I'm going to choose the top equation. So I've got 5 times 2 plus 6y equals negative 8. 10 plus 6y equals negative 8. Subtract 10, subtract 10. 6y equals negative 18. If I divide by 6 on both sides, I've got that y equals negative 3. So there's my xy solution, my ordered pair. Again, if you want to write that as an ordered pair, 2 comma negative 3 in parentheses works as well. All right, so big things there, just creating that opposite, and be nice to yourself, right? If you don't have to multiply both equations, don't. Just multiply the one that you need to create that opposite that happened down here in this bottom equation with the negative 2. All right, if you want to join me on this one as I kind of work through it, definitely feel free to pause the video whenever you need to, start it back up whenever you need to, but I'll just kind of talk through what I would do in this equation. So again, the thing that strikes me about this is there's no opposites, but I could easily create one with this 6x and 3x, right? Because if I multiply this bottom equation, again, by negative 2, well, now I'm going to have 6x in the top, and I'm going to have negative 6x down here in the bottom equation. So that's exactly what I'll do. So multiply the left side of the equation by a negative 2, multiply the right side of the equation by a negative 2. Top one stays the same, 6x minus 2y equals 10. Bottom one's going to change to a negative 6x, so there's that opposite. Looks like a plus 14y, and that's equal to 38 over there. Negative times negative is a positive 38. Add these up, my x's are going to eliminate because they're opposites. Looks like I've got 12y here, and that's equal to 48. If I divide by 12, I've got that y equals 4. So solve for y first this time, so now I need to figure out what x is. Again, I'll just choose the top equation. So 6x minus 2 times 4, there's me plugging in y, equals 10. 6x minus 8 equals 10. If I add 8, I've got that 6x equals 18. Divide by 6, and x equals 3. So again, if you wanted to write this as an ordered pair, make sure that you list x first, that's 3. The y is 4. Another good way to show your answer. All right, I'm going to skip around here a little bit, maybe try to find one that might be just a little bit different. And let's see, I might come back to that one. Let's go with this example. Let's go right there. So if you look at what we've got here, we don't have anything that's going to just readily create an opposite by multiplying just one of the equations. So this would be the case where you have to multiply both equations. It doesn't matter if you want to get rid of x first or y first. That's completely your preference. And this one I might try to get rid of the y's first just because they're a little bit smaller numbers. So what I'm going to do is I'm going to take this top equation, and again, I'm focused on making y opposite. So in my head, it would make sense if I had that top equation as like a negative 6y right there. And so to achieve that, I would need to multiply by a negative 3 on both sides. So if I said, okay, this y is going to change to negative 6y, well, I would need to make this bottom 3y become a positive 6y, so I've got the opposites. So if I multiply that side by a positive 2, multiply this side by positive 2, I should be able to have that idea happen for me. So distribute here. I've got negative 12x. Distribute there. I've got minus 6y. There's the start of my opposite. Equals 8 times negative 3, which is a negative 24. Distribute down to that second equation. I've got a 6x. Distribute there. I've got plus 6y equals, and then 9 times 2 is 18. All right, so I'm ready to add up these two equations. Looks like I've got a negative 6x there. Again, there's my opposites. Those y's are going to cancel, so that equals negative 6 over there. If I divide both sides by negative 6, I've got that x equals positive 1. There's my x. Process is the same. I don't know, this time I'll choose the bottom equation. Why not? So I've got 3 times 1 plus 3y equals 9. 3 plus 3y equals 9. Subtract 3, subtract 3. 3y equals 6. If I divide by 3, divide by 3. Y equals 2. So there's my xy at solution 1 and 2. So a good example there where we have to multiply both equations to create opposites. You could do anything that you want with that. I chose the y's. You could have chose to do the x's. Maybe you could have multiplied the top equation by a negative 3 and the bottom equation by a positive 4, and you would have had it. It's often the case that multiplying these things by like each other, like this is 4, this is 3, multiply this by negative 3 to have that opposite, multiply this by a positive 4 to keep that opposite. That usually works out well to do. So if you're stuck, that's a good thing to rely back on. I think I'm going to call that good. 9 minutes is good enough for that. If you have questions, we can talk about it tomorrow. I wish I could have been here today to teach this to you in person, but hopefully this video will suffice. At this time, if you feel confident, you feel comfortable, you can go grab your 6-4 assignment from the front table and get to work on that. Thanks, and we'll see you guys tomorrow. Have a good day.